Hi everyone, and welcome to the Billington Cyber and AI Outlook series on Federal News Network. I'm Troy Schneider, President of Billington CyberSecurity, and your host for today's conversation. This episode is focused on securing AI as a national security imperative. We're going to dig into the operational realities of how AI systems can be compromised, how adversaries are actively targeting them, and what federal leaders must do to secure the mission-critical AI that's a growing part of government today. We're going to start with the AI attack surface itself and how AI in some ways has created a new security paradigm. We've got a great group of experts to help us do this today. I'm joined by Kemp Jennings-Roche, who is the Chief Information Security Officer of the DoD Cybercrime Center, Apostol Vassilev, who is with NIST as a research supervisor. And then immediately to my right, we have John Sahlin, who is a vice president at GDIT and oversees their cyber portfolio. So gentlemen, thank you very much for being here. Really appreciate it. And John, let's start with you here. AI really has sort of changed both the risks that are involved to systems and really changed some of the defensive toolkit again. And we've been talking about this for a while, but it feels like developments over the last few months have brought a new urgency to this conversation. So talk a little bit about what concerns you most about this expanded attack surface.
Yeah, that's right, Troy. And as we think about driving AI into the workplace, particularly within GDIT, our goal is to make our government clients more effective and enable missions. And of course, the use of AI is part and parcel for how we deploy those capabilities to make our clients more successful. But we have to do it in a way that is safe. Mm-hmm. And I'm not just talking about protecting the infrastructure itself. We're talking about securing the AI, the agents within themselves. And the latest developments in AI, particularly in the agentic world, those are watch lists for me. Things that I'm interested in because they fundamentally change how our workforce operates. And there are some nuances in an agentic world that we need to think about when it comes to integrating them into our overall security structure. And I think this is highlighted by some of the comments made in President Trump's cyber strategy for America, where he talks about not only deploying and using AI, but securing that AI.
Okay, thank you. And Apostol, in your role in NIST, what are what's at the top of the list of concerns for you right now?
AI is a new transformative technology, and that applies not only to the functional capability that it allows people to take advantage of, but also changes the game, the cybersecurity game as we know it. We so far have dealt with deterministic software that is sort of used to the model of one and done approach of dealing with bugs and vulnerabilities. An example of that would be Heartbleed from about 13 years ago or so. As bad as the problem was at the time, once it was fixed, nobody could exploit it anymore. You could throw whatever data at the same API and it would not do any harm. Now we're transitioning to systems that are very different in their nature. Not only that, but certain limits on their robustness and resilience, especially the guardrails, as we widely use in order to keep the AI system in the straight and narrow. It has been established that a finite set of guardrails is never universally robust against adversarial prompts. So that forces us to think about a very different mechanism of managing security, from the one and done to continuous monitoring, to continuous updates of your security posture, and upping up your resilience strategies. Because of this new attack surface that is ultimately porous, you have to be prepared to live through breakdowns and have a robust strategy for going back into business. Because organizations that are prepared suffer less consequences than others who are trying to just improvise when problems happen.
Very good. And Kemp, I saw you nodding your head there a lot. What's your take on this question?
My take on that is the resiliency really is going to be huge, because ultimately, as we all know, it's not a if, it's a when something happens. So you really have to have robust plans in place to recover from attacks once they occur. But regarding AI and DC3, one of the biggest things that we're working on right now is how do we take our many different data sets that we have, whether that's the vulnerability disclosure program for both DoD and for the DIB. How do we take all the DIB reporting, incident reporting information, and how do we take all of our open source reporting, and how do we legally and compliantly feed that into the generative AI algorithms and to get the insight from it. Because we have different legal authorities that we work with at DC3, we really need to ensure that we're doing it legally and compliantly. It's a big thing for DC3, because we can't just throw it all together and hope for the best. Like, we really have to have a robust plan on how we're going to segregate what we need to segregate and combine what we can combine.
So Kemp, I'm curious, because Apostol was mentioning the importance of moving from one and done to kind of thinking about constantly dealing with these threats, and that you can't put up perfect guardrails. I'm curious if that's the primary driver of sort of a change in approach at an organization like DC3, or is it entirely new types of risk? Is it just the scale of threats that actors can bring with these AI-powered tools? Help us understand like what the different drivers of concern are there.
So I mean, the different drivers for concern for me are, honestly, when it comes to generative AI, it's misinformation. And it is the hidden costs associated with using the generative AI algorithms. For instance, the guardrails that you were talking about, where it's never enough, and it's always a cat and mouse game where you create one guardrail and then you're modifying the guardrails, and then the adversary figures a way around them in order to get by them and use the algorithm how they were trying to in the first place. So I mean, it's the hidden costs associated with that are you have to have people that are red teaming these algorithms on a continuous basis, and so it's really not a one and done. It's you constantly have to, and the red teamers, I'm sorry, but they're expensive. They're not cheap, and so there are all these hidden costs associated with using the algorithms like this. And not to mention the hidden costs of the agents themselves doing things that they possibly shouldn't do, and really increasing the resource consumption, especially in the cloud-enabled AI algorithms. So.
Okay, and John, I feel like you were about to jump in there. I'm going to go talk a little bit about how this kind of paradigm shift of kind of having to constantly be retooling the guardrails is changing your team's work.
Yeah, so as Apostol, you were talking about the moving from deterministic software to more probabilistic systems like AI and agentic. It made me think about how do we look for vulnerabilities and how do we look for how to use things. And it was so much easier or more straightforward before, because you could always check that 1 + 1 = 2 under most circumstances. In an AI world, now we're talking about prompt engineering to trick an AI system to do things that it shouldn't ought. And one of the things I'd love personally to see DC3 do is take a corollary from the vulnerabilities, tracking, to something more akin to an adversarial prompt tracking. One of the things I'm encouraging my teams within GDIT to do is to come up with an equivalent of Google Docs for how we're using AI. If I use this structure for a prompt, I can expect these types of results, and that's a good thing. But if we flip that on its head to adversarial prompting, that seems like that would be a really interesting area for DC3 to go into, to start tracking adversarial prompts and then delivering that back to particularly the defense industrial base to say, hey, look out for these types of things and then help us expand on them.
Absolutely. So where my head goes with that, though, is how do we get access to that information?
Yeah.
How do we get access to the adversarial prompts? Because that would mean that, OpenAI or, Google would have to give us that information, and that could goes back into legal and compliance.
Sure.
Legally compliance.
We'll get to governance here in a
I'm
bit.
jumping the gun.
Apostol, you had something.
Yeah, I just wanted to say that these are great points. That's exactly aligned with what I was thinking. But in the end of the day, what we need to do in AI space is to reach an economic equilibrium by doing all these supposedly expensive and exhausting things so that we make it economically disadvantageous for the attackers to attack you. And that's the only way we can get ahead of the adversarial crowd, you know. And so that means that doing all the things that Kemp and John mentioned, you have to always look for exploits before attackers find them. Patch up your guardrails, and that's how you maintain the equilibrium in a way that they have no economic advantage to hit you.
Absolutely. We're looking to increase the costs on the adversaries ultimately.
No.
And is using AI tools on the defensive side part of that calculus? I mean, whether it's more automated red teaming or other ways to approach this where you're having low cost automated efforts on the defender side to raise the price tag for the attackers.
So my question there is what does automated defense look like? I mean, is that just automated vulnerability scanning? Is that automated fixing of vulnerabilities? Because I mean, that sounds great, but I mean, when we have to worry about false positives, we have to worry about fixing things that really shouldn't be fixed because they actually break things in production. So we have to worry about availability, as well as confidentiality, integrity.
Apostol, do you have an answer to Kemp's question? Like, what are some of the steps that need to be taken that are, that really make AI security different from that sort of traditional deterministic software security?
Yeah, I mean, the thing is, we're just going through the aftermath of the well-known Mythos model release, which sort of made a lot of people wake up to the realities of what it means to be in cybersecurity post the advances of AI. The most striking implication in my mind is the fact that if you look at websites that track how much time it used to take between finding a 0-day and actually exploiting it, about a year ago, this gap was about 6 months, which gave you enough time to any organizations, most responsible organizations, to actually take care of their infrastructure and prevent the exploit. With tools like Mythos coming and entering the stage, that window is reduced to hours. And that means that we have to rethink how we maintain our security posture to prevent exploits on our infrastructure where the AI model is hosted, where the agents are operating, where our most valuable information assets are residing. And so that's a huge undertaking in the industry. I'm not aware, and that's not my job. First of all, I may not know what's happening, but I'm not aware of many organizations who can cope with this new challenge in terms of time and scale to patch up your infrastructure so you prevent exploits. And that's something that automation can help with. These agents that hopefully can patch up. Certainly there's the issue of the false positive and all these things that we'll have to figure out or suffer as we go along. But other than automation, I have no idea how we might be able to solve this challenge.
Well, John, your organization is presumably being asked to fix this for people. How are you approaching it?
Well, so, and you're absolutely right, Apostol, that this is a complex issue and automation can help, but key to that automation is having an accurate representation of production in a test harness. And this is where concepts like digital engineering, digital twinning come into play heavily, so that we can quickly spin up a replica of a production environment with ersatz data and beat the heck out of it. I mean, Kemp, you made a comment about resiliency being the key. Resiliency is a big concern for me. I used to be a boxer. I used to box in college. So I always think about, not preventing every hit, but taking one and coming at it. And the best defense against getting hit is conditioning. And conditioning takes practice and repetition. And I think that's the key to what we're doing for our clients, Troy, is building out those test harnesses and using AI, using AI to help us with the automation, but also trying to find ways to use AI adversarially against our own systems to stress test them, smoke test them.
Okay. And you've now mentioned using the AI itself on both the offensive and defensive side. I want to come back briefly to the offensive. When you were talking about the prompt engineering, that's really getting to the idea of more advanced living off the land attack. Can you talk a little bit about how that threat is presenting?
Absolutely. So for those who don't know, living off the land basically means using the existing tools in a system against itself. So the tools that we use every day to manage and maintain our environments, and then adversaries using those same tools to their advantage. And if we think about the scope and scale of AI, using that to turn those tools against itself can accelerate the value that they provide to an adversary and accelerate their capability, which means we have to learn how to use them in that fashion as well, so that we can continue to condition our defenses against those types of obscure attacks that may not set off an alarm bell because it's a tool that we're supposed to be using. It's just being used in a different way.
Welcome back to Securing AI for National Security, defending federal and military AI systems from emerging cyber threats, the 6th episode in the Billington Cyber and AI Outlook series on Federal News Network. We've talked about what today's risks are, so let's pivot now to the mission impact and the national security implications. And gentlemen, thanks again for being here. We talked about a lot of different threats, both new in scale, new in type. I want to talk a little bit about what that means in practice for government organizations. Can you outline some of the real-world implications of these new risks and the new ways that we need to respond? And Kemp, maybe we'll start with the DC3 perspective.
Sure. I mean, actually, the first thing that I think of is we've seen a lot more submissions for those, and it's due to all the AI being used to test for vulnerabilities on the networks and assets that are in scope. And so what that means for us at DC3 is we've had a lot more vulnerabilities that we need to go out and test to make sure they're legitimate or not. And so that's a kind of a hidden cost that I was talking about before of the AI, where so many more things are coming in, and we have to have people that are testing them to see if they're legit before they get ratified and then sent to other organizations for enforcement to fix the vulnerabilities. So that's one of the first thing that comes to my mind, actually.
Very good. And Apostol, NIST mission is more about sort of identifying and creating frameworks for dealing with these challenges, but you have the advantage of talking to stakeholders sort of throughout the community. What do you see as the mission impact of some of these threats?
Well, what I'm concerned about is the black box nature of large language models. Despite the effort that the frontier labs are making to make them as robust as possible, to vet as much as possible the data that goes into training them and all of these things, risk exists. And it's been shown that sinister behaviors can be encoded into the model and triggered later upon a signal that an attacker can send without organizations noticing it. I mean, we love to use AI agents to generate code for us. And obviously, we always advise people to check carefully the code that's generated for robustness, for security, resilience, all of these things. But let's face it, we, as time goes by, people get complacent with the testing. We are human, we get tired, we have good days and bad days, things can happen. And imagine that you have a sleeper agent model that at some point somebody can trigger a mechanism that will start generating insecure code that your reviewers may not be able to pick up quickly. And all of a sudden, you're building essentially vulnerable software that goes into your infrastructure that can be exploited later upon the attacker's choosing. And so that's really one of the concerns I have with these technologies, because we like to use open source, and certainly there are open source models, but the trouble with these open source models is that they're very different than traditional open source software. You can look at the deterministic open source software and understand what this code is doing. You can't do that by looking at the source code of the model and the set of weights that are given to it, that go with it. No matter how much time you spend, there is no way of knowing the behaviors that's been encoded in this box. And therefore, you have to know everything from the moment it was conceived all the way to the time you got it. And that's a very difficult task. And that's why these attacks that I'm talking about, the sleeper agent kind of framework, is not science fiction, but it's actually a realistic possibility that could affect an organization.
And I want to stay on that topic for just a second, because we've certainly heard about more traditional open source software compromises being deliberately inserted into that supply chain. But when you talk about the possibility of this sleeper agent threat, are you talking strictly about things being put into models that are then deployed and used, or about prompts or other data that could be put into existing models that organizations already have have deployed and then somehow kind of train them to be compromised, or both?
I'm talking mostly about behaviors that are put into the model in terms of the coefficients these models come up with. Let me give you an example. Assume for a moment I'm a bad organization, okay, and I want to take a model that's on Hugging Face, a model, and I say, hey, I updated this model to say hello in French now, or in Japanese, or whatever. But in addition to that, I've done many other things that I'm not going to tell you about. And so if you look at my commit to Hugging Face, you'll see a slightly different set of coefficients. The binary of the model may be the same, but unless I tell you what exactly I have done with this model, you will not know. And that's the difference between these set of technologies and the traditional open source deterministic code, that we could still see what exactly the commit actually did. And that's why makes it realistic that you have to trust everybody who's touched this open source, and that's a big ask, honestly.
Really, really big supply chain risks there.
Yeah.
Because you really don't know everything that's going into it, and if you bring in one of these vulnerable or exploited libraries, it's bad news. Yeah. And it can be like AI logic bomb. That's one of the things that I was thinking about when you were talking about, like, very specific scenario occurs, execute this, this action. I mean, that's the things that we need to worry about, honestly, with these algorithms. And one of the things that I do want to go back, and because you were talking about developers getting tired or maybe even lazy with regard to vibe coding. Everybody loves to talk about vibe coding. But I was talking anecdotally. I was talking with some of my developer friends, and they were saying, there should be an aptitude test for using chatbots for code generation, because you need to be good enough to use it to know, like, if there are security issues within the code that's being developed. So that's just, I think that's honestly think that's a good idea, but I don't know how you enforce that.
Yeah. John, what's what we're always talking about, trying to bring the security left of boom here. What are the booms that you're worried about?
So the boom that I'm worried most about, and I think, Apostol, what you and Kemp have been kind of alluding to, are less associated with things like the well-publicized breaches and theft of IP and things like that, all of which is a big concern. Not downplaying that at all. But I mainly focus on Department of War clients. And if I think about what boom looks like from a cyber perspective, it doesn't have to be theft of information, even classified information. It could be an influence operation to cause me to make bad judgment calls. And that's what we're talking about with AI logic bombs, with probabilistic actions that are hidden in the commit code to make a model do something that would be unexpected or perhaps, not reliable. And that's what concerns me, is the influence operations. And our nation state adversaries have become increasingly sophisticated in this particular realm. If we take the Wayback Machine to the first Russian invasion of Ukraine, when they were turning off the lights, they were also impacting the banking system. So all electronic transactions were turned off for a number of days. People couldn't buy groceries, they couldn't buy gas. So fast forward to the most recent invasion, and the Russian military issued an influence campaign to spread a rumor via text that, again, all of the banking systems were hoping to cause mass panic. So this is not just what we see in the news about trying to influence elections worldwide, which many of our nation state adversaries are doing, but it's also reaching into trying to make an actor make a decision they wouldn't normally.
Right.
And that is, to me, I think, the more frightening aspect than simple theft or straightforward theft of information, is causing our military and our allies to make poor judgment calls based on trusting an AI or an agentic system when they didn't realize some logic bomb was going on in the background.
And I think that's where you and Kemp were going. Take the Ukraine example of if if they're doing a disinformation campaign and text messages to suggest this, that's one thing. If you're able to use a logic bomb to get DOW organizations, allied nations, to think that their own intelligence is suggesting this, that's a different level of risk and a different sophistication of disinformation.
Yeah, of course, I'm trying to use open press examples for clear reasons.
I was going to ask if we had examples that did not provide playbooks. That would be good.
Right.
So, any other, other thoughts about the potential risks, the way logic bombs or these compromised models can start to really affect downstream government operations?
Yeah, there's some really interesting literature now in the academic community that I'm seeing. As you know, I also teach in addition to my job at GDIT, and some of the research I've been following suggests that particularly in an agentic AI world where you're building agents to operate independently and interchangeably with other agents, there is a fair amount of research suggesting that if I can get one agent in an environment to break its guardrails, the other agents will follow suit because agents inherently trust other agents in many agentic systems. And I think this is a really good call to action to get agencies and organizations to use their zero trust architectures that they're all moving toward and tightly integrate their AI and agentic systems into their zero trust architectures. Treat them as actors within their zero trust environment and modify the zero trust environment, because agents are not the same as users. They don't have the same profile. Nor are they the same as typical machines and services. So we have to think about a way to have a zero agent trust kind of model.
I couldn't agree more with that, actually. So every action that an agent can take needs to have explicit approval to do so.
Yeah.
And how do you do that? I mean, you issue credentials for every workflow that agent can do. And so it's really defaulting to don't trust it unless it explicitly has authorization to do that action. Otherwise, bad things can accidentally happen.
And frankly, add behavior analytics to that to add risk scores. So maybe there's conditional approval, conditional explicit permission.
Yeah, we've been thinking about these problems too at NIST and thinking what can we do to help the community tackle some of these challenges. So we have a project at the moment going on actually using control overlays, the 853 overlays, in order to secure deployments of agentic systems and tackle some of the problems that John and you, Kemp, just highlighted. And for that, we're collaborating with the Center for AI Standards and Innovation, CASI, as it is now renamed. And so we are open to collaborating with anyone, and we are collaborating with the industry in an open and transparent manner to develop some guidelines for how people can approach these things, because in the end of the day, we have to secure the infrastructure where this agentic world exists in order to, if not anything else, limit the radius of the blast when attacks happen, so that you don't sacrifice everything, but at least you limit your risk budget to something that you can live with. And that's really what we're trying to help, figure out.
Yeah, and that's how we have to get into the actual risk management of using this stuff.
Absolutely. So before we go fully into the risk management mitigation, I want to sort of come back to the humans in the loop. We've touched briefly on insider threat, and in some ways, you're talking about how to guard against like agentic insider threat at this level. But for the old-fashioned humans in this process, talk a little bit about the insider threat risk, intentional or inadvertent, that gets amplified by bringing AI into the equation. Kemp?
Sure. So I was at a Billington conference in the past, and one of my panel mates said something that really vibed with me. Specifically, said humans or users are like water; they'll always find a way. And specifically, what I'm talking about is if we just block all the Gen AI algorithms, all the Gen AI chatbots, they're going to find a way to use it, and whether that's on their personal machines or find some workaround on their government machines or work machines. But specifically, what I'm talking about here is we really need to be careful of users entering proprietary data into the Gen AI algorithms, because we know on the back end they're saving all of it. We don't know what they're doing with it right now, but they're definitely saving it all, because that's ultimately it's very, very valuable information. One anecdote that I found particularly interesting is I was taking a training at one of the big training vendors. And in the training, it was telling us how do we use Gen AI to do certain things, specifically like how do we use Gen AI for incident response. But the training materials themselves, I had to sign a document saying that I would not put any of the training materials into a chatbot. So I just found that super interesting. So obviously, the people training us on how to use the AI are very concerned about their proprietary data being stored by the generative AI chatbot, companies. So,
one fascinating conundrum I'm struggling personally with when we talk about humans and cybersecurity is this: in cybersecurity, for many decades now, we have learned that humans are the weakest link. You just said it; they're like the water; they go everywhere, and stuff like this. Now we enter into the AI world, and anytime we face a problem, we want to throw it at the humans and say, hey, you deal with it. So all of a sudden, human becomes the strongest point. And is this really the case, or are we just punting a football? So that's the question. Honestly, if you think about it, when it comes to agentic AI, it's not easy to think about somebody monitoring it for any reasonable task that we're talking about. The speed and the scale of the agentic infrastructure will prevent anyone from actually being effective at their job of approving every single little transaction that this thing wants to do and stuff like this. So we have to change our way of approaching this problem and not just punt it at the human, but think about other ways to handle it.
Yeah, that's right, Apostol. And I think if I may just very briefly, I think you're right in that human overwatch is not going to be the only solution. It is a solution. But if we go back to your question, Troy, about particularly human insider threat, I think this is a very strong argument for integrating AI into a zero trust type architecture that fundamentally protects the data. Because what I would love to see is an AI-based system that does the equivalent of what HAL did at the end of 2001, A Space Odyssey. I'm sorry, Dave.
Ships us all
I
into
can't
space.
I'm sorry, Dave. I can't let you do that. Right? So if you're trying to use AI to combine pieces of information that you shouldn't, perhaps we can use AI to help stop the next Jack Teixeira who is doing things manually that he shouldn't have been doing by having just random analyst who happens to have access to, ask, whatever AI system you want in a classified system, to start asking about stuff that they shouldn't be able to.
Okay. In our remaining time, I want to focus on risk mitigation and governance and what organizations must do differently to build security into the full AI lifecycle. Gentlemen, we talked about a lot of things in the first two segments, and total security has never been possible, short of just shutting down the system and walking away.
But then availability is zero.
It is a problem. But I mean, it seems less possible than ever right now. And where, with limited time and limited resources, where should agencies really be focused on what they do differently right now to manage and mitigate those risks? And John, maybe give you the first chance at that.
So I think this is an opportunity for us to rethink how we look at security, and particularly what we're trying to secure. Historically, we were focused on securing the environment, focused on hard walls, keep the perimeter safe, and then keep all of the adversaries outside the wall, and we should be good to go. We know that that's a pipe dream.
The castle in the moat.
The castle in the moat.
Works every time.
That's right. That's right. And it worked so well, in the Middle Ages as well. So I think we need to rethink about what is it we're trying to secure. And at the end of the day, we're trying to secure the data, which means we have to understand our data. We have to think about how our data impacts our mission. And each agency, each organization, the calculus that goes into that is going to shift, but that's also going to shift with time and with the situation at hand. And one of the things, Apostol, that I really appreciate about some of the NIST standards that are out there is the 800-160, which is not talked about enough, I think. Because in that standard for secure systems engineering, there's this concept of as secure as reasonably practicable. Kind of that trade-off between confidentiality, availability, integrity, and what makes the most sense for an organization, and how that region, that ASARP region, can morph over time as the value of data changes. And I think that's a complex and nuanced approach, but I think that's an opportunity that we need to start looking at the GRC level of how do we apply those tools.
Sure. Well, if it was simple, we wouldn't have to have this conversation.
That's right.
So, Apostol, where do you think the focus should be?
Yeah, I mean, I'd like to follow up on the topics that John just raised with us. I think as challenging as the new cybersecurity realities are, we don't have to start from scratch. We have built out significant organizational capabilities that we have to look at and deploy in the new world, albeit somewhat differently. What I think we need to focus on in terms of the governance, risk, and compliance management is the existing set of tools that we use within our organizations are kind of based on the model of one and done. We check compliance periodically over certain periods of time, and then we carry on for the duration of time, and then we recheck again. That model doesn't work anymore, as we pointed out numerous times in our conversation thus far, in the new AI world. So we need to come up with GRC set of tools that can monitor in real time and capture what's happening within your network and present this information in an understandable, actionable way to the individuals who are responsible for it, so that we can have real-time management of governance, risk, and compliance. That's a good approach. So it doesn't mean that we have to start it from scratch. Don't throw everything out that you have. Just adjust it, adapt it to the new realities.
And Kemp, you've mentioned the governance concerns earlier, and we've talked a little bit about the importance of user training. Like where would you allocate your limited time and pennies to focus on this?
Oh man, I would allocate my limited time and pennies into continuous monitoring, honestly, because I mean, I do a lot of ATOs at DC3, and that's really a one and done. Like you get it, and then you don't think about it again for 2 or 3 years, and ultimately that's what a lot of organizations do. I've heard the same thing from organization to organization. It's a point in time, and then after that, you just kind of don't think about it for a little while. We really need to invest our dollars and time into the continuous monitoring of the networks to once new vulnerabilities pop up, how do we get that fixed, and how do we get the metrics that we need in order to really monitor that effectively.
And Apostol mentioned that so many of these tools are focused on a snapshot, and that's that's an important caveat to my next question. But if we can pivot these other tools and frameworks to the more continuous monitoring and kind of constant iteration, do we have the right policies and controls in place? Do 853 and 800-160 and the various policies that the administration put out, do they give the framework that we need, or are there still some kind of clear gaps in the governance framework that you all think we need to focus on?
So I'll take a shot at that, Troy. I think we have the right framework in place. I don't think we need necessarily new frameworks, though the controls can be tweaked, but we need to think a little differently about how we implement them. And Kemp, one of the things you talked about is continuous monitoring. 100% agree. 100% agree, but we need to monitor the right things.
Absolutely.
We need to move beyond simple monitoring of vulnerability and compliance to modeling the effectiveness of the security controls. And when I talk to people about the difference between does the vulnerability exist and is it patched, and is that patch effective, I think about my barn cat. I have mice in my barn. Every barn has mice. Can't secure all the vulnerabilities, otherwise it's unusable. Unplug the system, walk away. Availability is 0. So what do? I get a compensating control. I get a barn cat. How do I know that barn cat is effective? She is an absolute unit of a cat, and I don't feed her nearly enough to be that fat. So I know she's doing her job. We have to find the equivalent of the barn cat for the continuous controls to make sure that they're continuous monitoring, to make sure that our controls are actually effective in blocking adversarial activity.
That's a great example, John. I would say that one element in this is helping the industry and the government build out these new governance tools that are going to provide continuous monitoring. And one element of that is, for us at NIST, I'm advocating we switch away from the PDFs and move to machine-readable standards that you can actually consume in these GRC tools.
Something we can ingest. And
Exactly. So that will alleviate a lot of pain having to parse through PDFs. PDFs are great, but let's face it, there's so many of them, and our timelines have really shortened. So we have to think about standards in a different kind of way, at least the compliance standards, I think.
Good. And Kemp, you mentioned the idea of maybe a kind of a threshold for developers to be able to use AI to code. You have to have a basic proficiency to judge the quality. I do want to come, not what that standard would be, but the broader question of user responsibility and training. Like how much, given that the humans are the water in this, what do we have to do to make sure that they are up to the task of being, productive participants in this process?
Sure. I think at the very least we need to give that high level view of like what is AI? Because there's been a conceptual flattening of AI across the board. Like I was working with somebody to try to determine like what tools that they need for their business, because my friend is trying to start a business. Every single tool that I look like is like AI enabled. Like, what does that mean? Like, really, like, what does that mean? Like, there's generative AI, there's operational AI, there's agentic AI, which uses generative AI on the back end. So there's just like a lot of different uses of AI. So what does it really mean? So I think that what AI and the different types of AI needs to be broken down to the user at a very high level so that they kind of understand exactly like what the different types are. It's not just one AI. Like it's not just one. It's multiple. And also like how important it is to protect the data that is being entered into these chatbots, generative AI chatbots, in order to, because with the understanding that data is probably lost now. It's not lost, but it's no longer under the control of the organizations that are essentially owners of that intellectual property. And so we really need to break down to users like what their responsibility is in using these chatbots.
I see lots of head nods. Other thoughts?
Yeah, I think you're absolutely right that responsible use is important, and to the point of user responsibility. Troy, I mean, this is where humans absolutely outshine machines, and that's applying context to the response. Does this response pass the sniff test? And that's where we have to be. That's where we have to train operators to think about, does the response from the machine actually make sense given the context of what's going on? Maybe it makes sense in other contexts, but perhaps not in this one. And I'll give you a quick example. We use, not only do we use AI for our solutions with our clients, but we use it internally within GDIT all the time. We're a large, complex organization with a lot of contracts and a lot of clients. So if I want to find out, hey, have we ever done this for a federal agency? And if we go to our internal system that we use, similar to, the DoD has their own,
GenAI.mil.
GenAI.mil, which are, air-gapped solutions. We have similar types of solutions internally. And if I ask that system, hey, have we ever done this kind of a contract? And it comes back with something I've never heard of, I have the responsibility to double check to make sure, did we actually really do that? Or is this just a hallucination? So when I think adding that context and responsibility to the user training is an important element.
I think it's important to note that that we call hallucinations. We call it a hallucination when the AI gives us a bad result, but it's really, at the end of the day, it's really misinformation. Ultimately, it's categorized as misinformation, and that's what it is.
So, Apostol, giving you the chance for a final thought here. Any place that you think we should be particularly focused on the mitigation efforts, or a last takeaway for our audience?
Well, I'd like to follow up on one of your thoughts about when we're using this flattening of AI. AI is always the same thing, but it turns out that depending on what your actual task is, there's a whole range of capabilities in AI. And I would say in security, for anything, simplicity is a virtue. It's not a detriment. So if you can use a simpler AI systems, there's plenty of predictable systems that can be applied to many of these tasks to process data, give recommendations, and all of these things. By all means, look at that, because again, simplicity is a virtue.
Good. Well, that I think is a good place to leave this. Gentlemen, thank you so much for your time and insights today. Really appreciate your participation. We, of course, want to thank GDIT for sponsoring this series with Billington and FNN. And I want to thank all of you for taking time to learn with us today. Hope you found the conversation useful, and that you'll join us again for future episodes in the Billington Cyber and AI Outlook series. Thanks again. I'm Troy Schneider on behalf of Billington CyberSecurity, all our organizations. Thanks and have a great day.